Hey guys, welcome back. So today we are looking at lesson 3. So let's go ahead and jump right in. All right, so for this first part, we want to solve for the value of x. So I'm going to end up doing 2 of these with you. I'm going to do them on my whiteboard so it's a little bit easier for me and for you to learn how to do them. So let me actually pull this right back up. The first one we're going to do is 5 to the power of x plus 1 equals 5 to the power of 2x minus 3. Now, I'm sure as you're looking at these equations, you're probably panicking because they look really confusing, like how on earth am I supposed to solve this? But I'm going to tell you, it's a lot easier than you think to take and solve them. So, like I said, we're looking at number 1, 5 to the power of x plus 1 equals 5 to the power of 2x minus 3. Now, the goal when solving problems like this is you need the two base numbers to be the exact same thing. So they're both 5, so we lucked out in this one. So that means all we have to do is take the exponents and set them equal to one another. So now we solve like we would any other multi-step equation. So we're going to subtract x. So we have 1 equals 1x minus 3. We'll add the 3 over. Sorry, I know there's back glare on there. And so we have 1x equals 1 plus 3 is 4. So x equals 4. So like I said, the key thing is these two numbers here, your base numbers, have to be the same value, and then you can set the exponents equal to each other. Now, in question 6, the base numbers are not the same. So what we have to do is convert. So we have 1 over 81. This can be wrote as a base number of 3 to some exponent. So the first one's going to stay the same. 3 to the x plus 1 equals 3 to the negative. Because the 81 is in the denominator, it's going to be a negative exponent. So negative, now 3 to what power is going to give us 81? Well, 3 times 3 is 9, so that'd be an exponent of 2. 9 times 3 is 27, so that'd be an exponent of 3. And 27 times 3 is 81, so it'll be to the negative 4th. Now, once again, base numbers are the same, so we set the exponents equal. So we have x plus 1 equals negative 4. We're going to subtract 1. We end up with x equals negative 5. Just like that. Now, I am going to show you just the starting portion of another problem just to kind of make sure you understand how to take and get the base numbers to be the same. So looking at number 5, it says 8 to the x plus 1 equals 2 to the 2x plus 3. So obviously the base numbers are not the same, but we can write 8 in terms of a power of 2. So this becomes 2 to the third times x plus 1 equals 2 to the 2x plus 3. And so then you'll need to distribute your 3 to both things. So this will be 3x plus 3 equals 2x plus 3. And then you'll just take and solve for x. So I'm not going to do the rest of that problem for you, but I got it started. So this is an example of what you would do for, you'll have to do this on number 3 and on number 4. So you'll have to do that on both of those when you're taking and doing those. You've got to convert one of them so you have the same base number, okay? All right, the next thing we're going to look at is the set. So we've got very long word problem here, so I'm going to read through it. So it's a bit of a story, and then the next few questions will all be about what is explained here. So in the fairy tale, Jack and the Beanstalk, Jack plants a magic bean before he goes to bed. In the morning, Jack discovers a giant beanstalk that has grown so large it disappears into the clouds. But here's the part of the story you've never heard. Written on the bag containing the magic beans was this note: plant a magic bean in rich soil just as the sun is setting. Do not look at the plant site for 10 hours. This is part of the magic. After the bean has been in the ground for 1 hour, the growth of the sprout can be modeled by the function b of t equals 3 to the power of t, where b is in feet and t is in hours. Jack was a good math student, so although he never looked at his beanstalk during the night, he used the function to calculate how tall it should be as it grew. The table on the right shows the calculations he made every half hour. Hence, Jack was not surprised when in the morning he saw that the top of the beanstalk had disappeared into the clouds. So, we've got this table over here, and it's going up every half hour, and we've got the different heights that our beanstalk is. So you can see it's growing really, really quickly. We start 1 hour, it's 3 feet. 2 hours, it's 9. 3 hours, it's 27. 4, it's 81. We keep going up, and look at how much bigger it keeps getting each time we go up. So it's growing exponentially. Now, exponential is your keyword for this lesson. Exponential. So right there, exponential. Now, our first question. Demonstrate how Jack used the model b of t equals 3 to the power of t to calculate how high the beanstalk would be after 6 hours had passed. You may use the table, but write down where you would put the number in the function if you didn't have the table. So we have this function here. We have the b of t equals 3 to the power of t. So let me zoom this in a little bit. B of, we want to know after 6 hours, so we're going to put 6 equals 3 to the power of 6, which equals, now if we go back up here and look at 6 was 729. So 729 feet. So that's how we take and can use the model to show it rather than just looking at the table. Now, the next question is talking how many hours. So you're looking for the hours it took to get to 243 feet. So we go back to our table and we find 243, which was 5 hours. So this is going to be 5 hours. Now, you guys are going to take and do 9, 10, and 11. Use the table to help you. That table is going to be crucial in you solving these. Now, for 12, we're going to use the table to find f of 7 and f, the inverse function of 11,364. So f of 7, we're going to go to our table, and we're going to plug in 7 into it. So we go to 7, and we find that it's 2,187. Sorry, I have to scroll back and forth so much. 2,187. Now, the inverse of 11,364, basically what that means is instead of looking as having 11,364 as time in our function, it actually is representing the height. So 11,364 is right here, and that is at 8.5 hours. So it's just using essentially the y side of the table to find the x value versus using the x value to find the y value. So you'll do the same thing for 13. Now make note, f of 9 and the inverse function of 9 are two different things. They're going to be completely different answers, okay? All right. The next section is back to evaluating functions. So we have been doing a lot of these. We're going to keep doing them. So you guys are going to be really, really good at solving these. So we have our 3 different functions. F of x equals negative 2x, g of x equals 2x plus 5, and h of x equals x squared plus 3x minus 10. So I'm going to do 3 of these with you. The first one I'm doing with you is 15, f of b squared. So we use our f of x function, which is right here. Sorry, trying to adjust the light. So we plug the b squared in for x. So we're going to have negative 2b squared. So there's our answer. Remember, those are typically the easier ones where we're just plugging in a single value. Number 20 is the next one we're doing. It's a g of x one. So we have g of a plus b, and we're plugging into the 2x plus 5. So we're going to have 2 parentheses a plus b plus 5. Now we have to distribute the 2, so we have 2a plus 2b plus 5 for our answer. Now, the last one is going to be the most complicated. We have h of x equals x squared plus 3x minus 10, and we're plugging in a plus b in for x in each case. So we're going to have a plus b squared plus 3 times a plus b minus 10. So now we have to FOIL this right here. So this is the same thing as having a plus b times a plus b. So we multiply the first term, so a times a is a squared, plus outer a times b is ab, plus inner a times b, so ab, plus our last terms. Sorry, you couldn't see that. B squared. So then plus, we distribute the 3 to both things here, 3a plus 3b minus 10. Now we combine like terms. So we've got a squared plus 2ab plus b squared plus 3a plus 3b minus 10. So a very long answer because this whole entire thing right here is your answer. Like I said, it's going to be the most complicated one that you guys have on this assignment. But it's all about just plugging in what the value is and evaluating the function for it at that value. Even though it's not necessarily a whole number, it could be an expression, it could be a variable, it just kind of depends, or plugging in an entire function into another function. So if you guys have any questions, feel free to ask. Your keyword for this lesson, remember, is exponential. Have a great day. Bye, guys.